Here's the cart with one rotor, wire drive, variable beta angle mechanism. Start off in turbine mode. The wind is coming from this direction. The cart's going that direction. This little wind indicator is showing the direction of the wind at this point. Streamline airflow. Notice this blade is stalled right now. It's stalled, but its lift vector is pointing backwards. So this is acting as a turbine. When that force is in this direction, it's propeller. In this direction, it's turbine. Because this blade moves in this direction as the cart goes that way. Okay, now as it speeds up, we get an induced velocity vector of the air to this wing, which causes the streamlines to be coming in at a different angle as it goes faster. And you notice it'll reach one speed right here where the wing becomes unstalled and starts flying very efficiently. And the force vector, this is the total aerodynamic force of this blade acting on one point, the resultant of all the others, acting right here, and it's in that direction, which has a component in the direction of travel of the blade, which means this is a turbine. When the blade is providing energy to the shaft, it's a turbine. Once it becomes unstalled, we want to maintain that angle. So, and that's exactly what we do as it goes faster and faster. There's a couple of speeds that we get to that are interesting. That's one. That's the Turbpeller speed, where the lift force does not have a forward component or a reverse component. Reverse turbine or propeller. This is a Turbpeller. And then if we continue in that direction, notice the angle of incidence here. It's still coming from behind a little bit here until we get to right here where the wind is coming in straight from the side. That means there's no component in this direction anymore. We're at wind speed. There isn't a headwind yet. Still no tailwind, so it's coming straight sideways. But we're still at this really good angle of attack here. We're going to maintain optimal angle of attack throughout. So it's in propeller mode now. And then as we accelerate further, this still provides enough force to make us go faster. So here we go until we start getting the angle coming from the front here, which means we're going faster than the wind. And this is, it's not going to go, this is exaggerating, but it's not going to go this far, but let's say it does. Notice the air is coming in at this angle, and the lift vector is strongly in that direction. Propeller mode, it wants to slow the propeller down, which is, propeller's moving this way and this is fighting it. This requires energy from the wheels. But let's say we do something right at this point. Okay, we're going at max speed. We're going to throw the blade like that. Negative angle attack hitting this wing. This force vector is going to be on this side now, pointing that way. If you look at the angle of this thing and the angle of the reverse thrust, this is the reverse thrust vector. The reverse thrust vector also has a turbine component. So from decelerating from highest speed, you throw the beta angle to minus angle of attack. Reverse thrust is going to cause a turbine force on the shaft. As it slows down until it reaches, notice that the force vector is still going this way because we've got a reverse angle of attack, until that gets to where you've got the other Turbpeller speed. When you're slowing down from maximum speed under reverse thrust, you'll pass through another Turbpeller speed that occurs when you're going faster than wind speed. But anyway, that's pretty cool. Ridge Runner out.